The Security Weekly News is live on Tuesdays and Fridays at 12 o'clock Eastern Time most every week. I try to scan and produce a quick look at some major stories to help you keep up with what's going on in and around the industry in a short format. Myself, Jason Wood, and other guest commentators provide greater insight every week. I'm Doug White, and I hope that you will look for the Security Weekly News in all of your favorite podcast catchers and subscribe for the latest content.
Welcome back to Application Security Weekly. We just talked with Huxley Barbie about the poor history of OT devices, brittle network stacks, and what the next 30 years of OT security needs to be successful. I'm your host, Mike Shima. I'm here with John Kinsella. It's just about time for the news, but first, one announcement. You can now find us on Instagram. Follow us for highlight reels, giveaway announcements, and more at Sec Weekly. And Mr. Kinsella, you gave us a little bit of a tease at the beginning. How many punch cards does it take to watch Application Security Weekly? And I couldn't even find one, so punch cards. So I've got none here, so I'm a bit worried about what this number is going to be.
I'm still working on the calculation for that, but I was thinking about this last night from spending a little bit too much time on YouTube, and I came across this really neat video. It's about 30 minutes long. And it's a video of literally the physical copy, the last physical copy of the Apollo 12 source code before it was sent off to Raytheon to program into the core memory to upload into Apollo 12. So it's about 6 inches thick of tractor paper for people who remember what tractor paper is. But it's a neat video. They sort of walk through, they do walk through sort of, how each line is laid out. It's all assembly language, right? We didn't have higher level. This is from 1969. So it's, assembly language. It's all sort of laid out with like memory locations and how it's being used. There's references to the previous time that symbol was used. There's a symbol table in the back. It's sort of neat to see the way they had created enough functionality in the assembler. So when they printed this stupid thing out, because they're going through debugging by hand and sitting in meeting rooms trying to figure out what the line is to add or delete, they could actually understand to some degree how the code was being used or what was going on with it. And then on top of that, excuse me, they have there was a bug, what was known as the 1202 error in Apollo 11. So when the thing was coming down to land, I guess one of the modules sort of got confused and started sending signals back to the CPU because it was hardwired, not even hard-coded, but hardwired back to the CPU. And that was actually making it difficult to land the lander. So they walk through how they found that bug and how they actually patch it in the code. So it's sort of neat, but yeah, the code was loaded in about 40,000 punch cards, which then get loaded to tape. Luckily, if they're patching the code, they only have to re-upload the punch cards, which are have to patch. But yeah, so I mean, that's for, a machine with what? I think like 1K, not even 1K memory. So we're looking at probably billions, I'm guessing, of punch cards for an episode of ASW. And then you've got to watch it, and then our folks who are recording it. So yeah, it's probably, I don't know if it hit 1 trillion, but it'd be fun to do the math. If any of our listeners want to sort of get active with Excel or something, Google Sheets, I'd love to work on that with somebody. That'd be sort of fun to see.
That is amazing. Just imagine the pair programming, the how do you document code, with the institutional knowledge
so that's
in an approach
actually
like
one
that.
of the things which is interesting about this, at least to my nerd brain. I mean, there's a lot of, my wife left the room 2 or 3 minutes into this thing. She's like, I'm done. But so over half of each line was for a comment or could be for a comment. But if the comment was too long, you'd have to use a second punch card for that line. So that's right. Suddenly, like, what's the assembly language code, which think about the actual assembly or the actual code itself are probably maybe 5-6 bytes. But once you start actually adding in comments and things like that, it gets expensive. I mean, I think they were looking at, it was $1 or $2 per punch card, right? So if you have a comment that you're actually, some of these multi-line comments, you're talking about costing money. Anyways, I thought it was sort of neat to think about, like when we were talking about debugging or stuff like that, back in it wasn't even my day, I wasn't alive, but back in someone's day, it's a lot more difficult than is for us lucky folks.
Yeah, and if we even just said like napkin math, $1 per punch card, that's a very specific cost of bugs. So I wonder what how could we translate into $1 per line of code today, or screen page, something like that.
it's so also, and this is a fun video for folks to watch. These guys are really nerding out on this stuff. So they've virtualized, they've got some of this code, well, all this code to work in a virtualized environment. So they're able to actually run it and land the lander. So they show landing it with the patch in place and like how it actually goes through. But my thought would just be like, yeah, if they'd written, it'd be interesting to see if you take that code and write it in a modern language, how many lines would it be? Like, what does that compress down to? An inch, maybe half, probably a quarter inch, you think, of printout if we found a tractor paper printer. But yeah.
Time for code golf. Yeah, put it into the Python, Go, Rust, all the different versions. You were geeking out on that. I was geeking out on something a little bit more modern. I was reading through the heap overflow that came out in curl. Now we covered the build up to that last week, and this week I did want to revisit it just because Daniel Stenberg, huge fan, he wrote up just how I made a heap overflow in curl, and it's a nice walkthrough on the concept of writing a program, which I think ties in pretty well to assembly and punch cards. And this was basically, he was fixing an old bug or an old feature request for the SOCKS5 proxy, and had a little bit of a mix of introducing a new state machine, but mishandling some Boolean logic. And as he says, as almost an aside, there was an if statement, a true-false condition that was from leftover code. And at the time when he added this feature, he did a fallback. So rather than do only a remote name resolution, it did a remote name resolution. If that fails, it will go to a local name resolution, which can have more than 253 characters, blah, 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 thus a heap overflow. But he says if he had just chosen the design to fail, that the user asked for a remote name resolution, let's stop there. We fail, probably this wouldn't have been as bad, or at least would have been more detectable if that bug exists. And I thought that was a really nice, insightful comment design idea of how do we as programmers either just say stop and fail versus let's try to accommodate and help the user out as much as possible.
That's interesting. So yeah, folks, this is how we spend our weekends. I'm nerding out watching YouTube videos around, Apollo 12, and this guy's reading Stack Overflows or buffer overflows. I hadn't read through this one as much. I was looking at the write-ups of the two vulnerabilities which came out last week. There was this one, and then second one on it's out there. I'm not gonna track it down. But the way you just said that, or the way he said it, of if it had just failed and stopped, a core part of me is I don't want to just fail something, an application I'm running, right? I want to either return an error or somehow handle something gracefully. And this is something which developers frequently don't do, not because it's insecure, but because that takes more effort, right? Because then you have to have the other use cases and what if and think through those type of things. But now on all that, top of that, we have to say, you also have to think about security, which is sort of interesting, right? It's a bit of a head scratcher there. It's like, okay, so not just do we have to check that it's, is this coming from the right place? Is it long enough? Is it being used in a correct way? Or we could just return back and say, no, you're wrong, or I can't do that. And so I see the security in the simplicity, and simplicity is usually better. But at the same time, from a usability point of view, that's interesting to think about.
Yeah, I think part of the things that we're trying to think about too are some designs of approaches. And you were talking about the Apollo design. We've talked about designs the last couple episodes. There's some other standards, some other design adjacent considerations I'll say here. You grabbed an article from the OpenSSF that was looking at a security insights specification. What exactly are we getting insights about? Specify this for me.
First of even the title of that thing is sort of a little off. If I'd known what it was, I probably wouldn't have gone down this path. So the security insight specification is a standard which is being released. This is version 1.0 from the OpenSSF. And really what they're trying to do here is, think over the last, I'm going to say 5 years or so, we've started at maybe 10. we've started adding like either contact.md, contacts.md, or security.md to our project, so that people, if they have some sort of a security issue, they can go, who do I send this to? Who's responsible for this? Is there a process behind how we do it, or how people are going to respond to it? All those type of things. But that's, either a wiki or a markdown page or something like that. It's a very relatively casual document, right? It's not like something like a YAML doc. So what they did here is they're saying, hey, let's make that machine readable. Let's make this something which is, very defined on what it is and what's going to be in there. And they've got an example that mentions it goes down to a level of what's contribution policy. Do they accept pull requests? What are distribution points? Who are the security contexts? Who do we send vulnerability reporting information to? But the intention is to do it in a way that I'm guessing can then be gathered and sort of collected into a database somewhere. But you've got an article on SBOM that I want to sort of bring in here and sort of bring the two together. Mm-hmm. But the first thought I had on this leading is that is, and I'm not saying yes on this, right? I'm sort of I'm setting this up for the conversation, the head scratcher. I'm not super sold on LLMs. They're interesting, but I don't think they solve everything right now. We had an interesting conversation about this on Enterprise Security Weekly last week for folks who want to go listen to that. But the thought from me on these two things is, do we need to keep writing these specifications and the requirement to use YAML or things like this, if we've got LLMs which can go ahead and be asked to translate something for us or get this information for us? Do we need to have a specification like this in the first place?
That's an interesting aspect, because I was looking at the YAML, and YAML is at least relatively is better than XML, a little bit better than JSON just for readability, and as long as you've got unless you've got JQ on your command line. But I was looking at the examples of the site, and the examples were, at the moment, maybe a little underwhelming for me. I'd love to see more of a worked example rather than the lorem ipsum, because part of it, the verbose version of the security insights includes like descriptions of the security testing, what security assessments have been done, even threat models or the dependency list. And that dependency list starts to get into that aspect of, well, why not just an SBOM instead? But as you were describing this, I was thinking of, why can't a lot of this just be automatically generated from the GitHub repo configuration or GitLab or things like that, which does seem like a case for LLMs to bring that in. Which would also be fun, though. How correct would those be? And maybe where I'm coming at this is, do I want to just edit and correct a little bit of LLM and spend a few minutes, seconds of my time? Or do I want to put together the YAML from scratch and figure out the indentation and to get the colons in all the right places and figure out the multi-line versus single line? Because that still messes me up every time.
Mm-hmm. Yep, it's back to our Fortran days, right? So a way to think about that, another way, we're talking about what you're describing is you want something, if it's YAML, we were talking about the reason that people want these things is they're machine readable, and you're talking about something being human readable, and there's what's that mixture in between? Mm-hmm. But the sort of question I have back to that is, what's machine readable in 2023? So do we need to have a CSV or a YAML or an XML or a what have you, when you've got these things out there, which should be able to learn and understand what the common format of these things is? This is a loaded question. The more people think about it later. But do we need, what is machine readable? That's sort of the thought here from me.
I like that a lot. And quite honestly, natural text, natural language feels much more, let's pull that into that umbrella of machine readable, because that seems very appealing. The other thing here is we've got a lot to get through, so I'm going to try to march through our time here, John. You did mention this SBOM article, and this stood out to me because a little bit of polite trolling here. This is something from the OWASP Foundation that is not a top 10 list. I'm hoping a top 10 list does not come out of it, but they're doing something that actually feels pretty impactful. So they're working with ECMA International to bring CycloneDX into a standard. And two things stood out to me. One is that working with ECMA International means, unlike ISO standards, for example, this will be freely accessible. You don't have to pay an exorbitant amount of money just to read the spec, to download it, or to be a member of the organization to influence it. So I like that. So that's a smart choice. The other thing is that, yes, we've been talking about SBOMs and CycloneDX. Also, if you go to their site, they'll talk about SaaS bombs and being able to express, vulnerabilities, known vulnerabilities in these things. So it does feel human readable, aka machine readable, and it seems like a positive project to put some weight into.
I search for my mute button. It does. I'm wondering if, so I had a thought there for a slight side. We're trying to figure out here on the Application Security Weeklies, how can we sort of control the prevalence and spread of these top 10 lists? I wonder if we start referring to them as security listicles. So in other words, it's just like the BuzzFeed has a top 10. Maybe we start, maybe that would actually sort of drive the knife in and turn a little bit of people who keep coming up with more top 10 lists. I'm really curious to see what comes out of this from the concept of the idea of mixing SaaSBomb plus the SBomb in a way that's a standard that's open and being used like this. It's exciting to me. It has exciting potential. How about that? So I'm sort of curious to see how it goes down. I think, as you were hinting, it's going to move faster than if it was an ISO project. So maybe we'll see something out of this sooner rather than later.
So speaking of things that perhaps don't move fast, and also another dip into history, not quite back to 1969, but it was 20 years ago this month that Microsoft released their first Patch Tuesday, and worked through it, which is kudos to them. And in the article too, I included another article that was about a little bit of the history of the trustworthy computing push, the Halloween document. I think that was famously referred to from Bill Gates, saying that we've had a few embarrassing things, like I think it was SQL Slammer, NIMDA, a bunch of other IIS had a lot of problems. And they're like, let's turn this ship around, and to use other metaphors. But I thought it was interesting in combination with a couple other articles. One, Windows is saying they're finally putting NTLM on a deprecation path so that everybody can go in and deal with Kerberos. And now all of the pen testers and red teamers are going to have some new tricks besides just pass the hash and popping an Active Directory. So sorry, you're going to have to work a little bit harder now. Yes. Maybe not too hard, but we'll see.
Herb, I'm curious. It might be interesting to have Tyler or some of the other guys who have recent pen test experience on the show. When I used to run Curb, it's difficult to set up and get it going, but so it's secure and it's been around for a while, and kudos to MIT and everyone else who's worked on it. But my thought is, if that is not set up correctly, do you start seeing security issues there? I mean, it would be interesting to see, because now I think what's going to happen out of that, Mike, is once these passing that hash type things go away, people are going to start researching and focusing on other parts of Windows. So it'd be interesting to see what they see as a result of that, other parts of Windows authentication. Yeah, to keep the show going, long live NTLM. But thinking about this, and then you had another article on Patch Tuesday in here, and sort of thinking about how that plays into things. And I wanted to tie that in with an article I had on the Mac. So this is sort of it's a piece from Macworld, very user perspective. Their headline is "Apple's mission to make the Mac safer is slowly destroying it." And so what's going on over the last few years for those who aren't Mac people? You're seeing this with Android too. We'll start off thinking about the mobile device side. As people care more about their security and their privacy, specifically their privacy, they want more control. They want more ability to say, excuse me, who has access to my camera or my location or my files or my photos or things like that, right? And what's going on with and that can be annoying, right? If you get a brand new iPhone or Android device, Samsung, or pick your poison, and start using it with a bunch of apps, you're getting a lot of these little dialogues saying, do you want to do this? Do you want to do that? What should you be able to do? And you have to do, head scratching seems to be my thing of the day. You have to do some head scratching on each one of these and sort of go, do I want that or not? Or when do I want it? Or they're not simple yes, no problems, unfortunately, or prompts. In Apple's case, what's going on is they're trying to sort of slowly bring the architecture and possibly the platforms of iOS and macOS together. We're seeing these type of dialogues pop over into macOS. So what's interesting as I think about as I put this in there, for me as a sort of a long-term Mac user, it's a bit of slowly boiling the frog, because I might get a prompt every few weeks or a few months, right, to say, hey, do you want this? Yes, no. Okay, fine. But the point of the article is, if you're with either a new iPhone, as I mentioned before, or a new Mac, when you start using apps on there, you're just flooded with these dialogues of like, should I do this? Do you want to do this? What's going on? And the point is, they're sort of killing the fun of computing, to use my take on it. And this comes back to usability. So we're talking about a few stories ago, Mike, of how do we want people to have that flexibility to control these type of things, but still, like, death by 1,000 dialogues might not be the best way to do it.
And one of my reactions to this article too was there was a miss of, or maybe not as much of an appreciation of different threat models, meaning your threat model is not my threat model. And we've seen on the iPhone, for example, they introduce also lockdown mode. So rather than just, answer a lot of privacy pop-ups, for example, you can just opt in to a more secure version that doesn't automatically render images, render videos, things like that, which is good. And that's been proven to be protective against certain types of 0 days. On the Mac, perhaps this is what it's the author's also looking for, saying, I actually intend to have my command line and I want to have my console go into the downloads directory and documents because I'm hopping around all these places. Whereas other users, if they get phished or they social engineer to download and run something, it's that classic, why does this flashlight app need geolocation information? Why does an app I downloaded need access to my documents directory? And so I think it is trying to protect a wide range of users, but hopefully it does still maintain an appreciation for usability and doesn't go the way of, speaking of Microsoft, I think there was the UAC, which was never a security boundary. It was always just a kind of that nudge of, you sure you want to do this? You sure you want to do this? And whether you clicked yes or no, it wasn't really helping you either way. It was kind of a weak form of training. So let's not see the macOS go that UAC direction.
Yeah, and it's going to be interesting to see. I mean, it's in my world, what comes to mind is allow me to not have those dialogues and just give me a list of things I can just go through and click for a bunch of apps at once, some sort of matrix or something. But I can see that being super confusing to some users. If like you go away on vacation, you come back, you've got this dialogue with like 20 or 30 things with like 5 permissions in each, right? It's a very enterprise security problem or experience. But is there some way to balance in between? I think that's what's going to be interesting to see is how do you do that? Or I don't know.
Yeah, and I think the way I would also add to that is how much should we make sure we're not just shifting the burden onto the user? Meaning, something bad might happen. Do you want something bad to happen or not? Which is the leading question way of phrasing that. And I know that's not exactly what they're doing, but this is the path that is fraught with danger. Should they continue like that? I'm going to do another segue. You did mention LLMs, and Microsoft, speaking of the future now, they do have a bug bounty program around the Bing experience. And we've talked about bug bounty programs for many reasons. This one I actually liked because if you click into what they're actually paying for, they're not paying for the cross-site scripting, the SQL injection. They're not paying for like weird implementation artifacts around the AI. They're actually very specifically saying, here's some inference manipulation, things that means that you're causing the AI to show content to other people rather than just getting it to shout obscenities to yourself because you've bypassed some restriction on it. There's also some other things around model poisoning, data poisoning, or trying to extract information about what the training data was. I mean, here's some member data, here's some specific attributes. So I do very much appreciate the specificity of that. So it feels like a bug bounty that's actually well designed and is going to be more of, here's an SSF in the Bing AI model. Things that would be boring and generic, they're already covered in a bug bounty.
One of the things we've talked about in several different ways over the years is when is it a good idea to have a bug bounty or not? And where I'm sort of thinking and going from this is it too early? Is it too soon to have this? I mean, we're seems like we're seeing enough low hanging fruit out there. Like, we talked about the grandma captcha recently. Is it? It feels to me like it might be too soon to have the captcha, too soon to have the bug bounty. And I get it. I like that they've set it up. I'm trying to ignore the marketing on it, but that's just me.
Yes.
Yeah, I think it'll be interesting to see how does some of the larger ones like HackerOne, do they have to modify their bug bounty program to support LLMs? I'm guessing there's probably already some in there. If I get a chance to go look. But that's sort of where it's coming from for me. I think I'm glad they're doing it. I mean, the reporting and researching side of Microsoft has always been good. Can I say that? I think I can. At least for the last multiple years, decade plus. So I can see it wasn't a stretch for them to set this up and add it and have this in there. It'll be interesting to see what they get out of it. Is it a lot of these low hanging fruit, which I'm talking about, or is there people going to be figuring out ways to get into Azure through Bing? Bit of a jump there, but I'm showing the ends of the.
No, yeah, bit of a jump. I think that's a good thing that they're focused very much on the data oriented aspect of this. So mostly be curious to watch, because they're also talking about what's important, what's critical. But interest of time, I'm going to skip over to let's go back to some network type of issues. And one was there was a big DDoS that Cloudflare, Google, some others wrote about. And what was interesting about this is it was in the HTTP2 protocol. So here is some fun protocol analysis that was and ways to make it to take advantage of it. So I always like protocols. I always like reading them. They can be done. We talked about the ping of death and the OT approach too. And this was just a fun way of attackers finding fun ways to be surprising and take advantage of this. And I cut my lip, so excuse me real quick. John, take this over. I don't know if there's something that you've got here.
As he says that, Mike Shima, I always like protocols.
Yes.
Listeners, why are you still listening to us? I thought this was interesting. So let's see, what's going on here is they found a way basically to use a performance feature in HTTP2 to really do multiple higher scale DOS. Wow, I'm really sort of looking like I don't know what I'm talking about, but I do. Believe it or not, I actually read this. So what's going on here is the ability to really just send a ton of hellos down that pipe and then just drop them and hang up on them. And do it again. And then there's some modified ways of doing this where you'd actually keep those connections open a little bit longer. From the provider's point of view, if you think about Cloudflare, why they care about this is they're, beside being a massive HTTP2 and also HTTP3 farm, they want to try and be able to minimize this being used as a path of attack for their customers. So it's interesting to think about and I don't think they're keeping quiet, at least from what I read, Mike, about how do you actually disclose what happened? How is this, or excuse me, they're keeping to themselves, how do they protect against this? And I think that's the interesting part to think through. It's like, what is the heuristic you're looking for that someone's actually taking a web page and they're loading all the content on it through Cloudflare in one HTTP2 connection versus, we've hit a threshold of this is actually a DOS happening over that same connection. So, and then on the reverse side of this, as you saw when you're nerding out the protocol, there's the concept of being able to send a polite no thank you back to the caller as a way to sort of shut down that connection or that series of connections over that HTTP2 connection. But my impression is that was really just a polite no thank you. It wasn't a stop and go away until you send a reset on the connection. So it was interesting to see the protocol itself, how this works. And then they're saying it has some effect with HTTP 3, but probably nothing to be concerned about there.
Yeah, I thought that was interesting too, is that aspect that, like in the Google article I listed too, they were mentioning, let's look and see, does HTTP 3 have a similar problem where you can open 100 sockets and who knows how and keep them open, and rather than a malicious client being able to say, you know what, I'm not going to politely go away, but the server has to figure that out. And how does the server make that distinction between this is the human versus this is the LLM or something else that has come to play around with me? Speaking of, go ahead.
Well, briefly on that, that's one of the interesting things about that is if they're, and again, I could be wrong, but from what I've seen so far, they're not really talking a lot about how they're protecting against this. But that means anyone else who's also running HTTP2 servers or farms has to figure out a way to, how do you deal with this at scale? And you can sort of think through and do that, but it must mean that the way to prevent is, I don't want to say fragile, but for now I'm going to say fragile enough that once you think about it, the attacker might be able to modify what they're doing to get around that. Or so it sounds like this could be a bit of cat and mouse.
Cat and mouse, yeah. And they did explain too, they'd already seen HTTP2 being abused, misused over the summer until it finally got to a point where it was really impressive DDoS attack. So there's always some tweaking, which is interesting. But John, you've also got a Squid proxy, speaking of the web, that has kind of a lot of vulns in it.
Speaking of proxies. Yeah. So this was a little shocking. So Squid proxy, for those who don't know, it's been around at least, I think, late 90s. It's one of the older, to me at least, HTTP caching proxies. And it can be used, I think, for other than HTTP, but that's at least how I know it. So it's exactly what I said, right? It's designed to be a large scale proxy, which before someone like Cloudflare came along, this is the way you either protected, save bandwidth on your enterprise, or if you're using actually running web servers, sometimes you'd put a proxy in front to sort of cache outbound if you weren't using Akamai or whoever else. But in this case, a researcher did a bit of the researching and found 55 vulnerabilities, including 35 ODAs in the Squid caching proxy. So some of them date back a few years. They've just been sitting there in the code. But the list, Mike, is it reads like a top 10 of top 10. So we've got stack buffer overflows used after freeze, exported for Stack Overflow, chunked encoding Stack Overflow, memory leaks, more memory leaks, buffer overreads, null pointer dereferences. For those who had the bingo card out, you must have got it by now, but we'll keep going. Assertion on IPv6 host requirements. It just keeps going and going and going. Buffer underflows, more null pointer dereferences. So it looks like it could use some love.
Yeah,
I think is the best way I can put it on this one. I'm not sure how popular it is nowadays compared to say 5-10 years ago, but and the other aspect, at least for me, is I think a decent number of folks were using something like this. You think of for a lot of the attacks we have out there, HTTP attacks, the response has been to put a proxy in front of it and let the proxy, which knows about what the protocol should be, let it handle the parsing and understanding of the HTTP protocol so that if there is a vulnerability in there, you don't have to worry about patching your web servers or your application servers. But now if we've got this thing which is looking a little like Swiss cheese, that is going to give at least me some pause. So hopefully to get this cleaned up.
And it also, I'm going to tie that back to curl real quick, because this list is a kind of a good reason to say maybe we shouldn't be using Squid, or Squid needs a rewrite, or an alternate, something else that is a memory safe implementation. Whereas curl has a pretty good history in terms of security. It still had race conditions, memory issues, what have you. But in that post, he's saying that porting curl to another language is not on the agenda. And he says, patches welcome, but it's going to be piecemeal. And it's going to be a very small kind of approach to writing curl in anything else, which I think is reasonable given its current design and history. But that's what I've got for this week, John. Anything else you want to wrap us up with here?
I saw your comments in there, and I was a little shocked that you didn't want to rewrite that in more modern.
It's the one thing that I'll make an exception for. I know, exactly.
And then there's a comment in there about or a snarky comment in there about the security insights. They could put into their security insights YAML that pull requests are indeed accepted. I sort of wonder about any project that says no on that. But anyways, let me think. We got, that was that one. There's one more I'll cover briefly, and then we can wrap it up. So I think in the past, we probably talked on here, I'm talking about Visual Studio. Visual Studio Code has I'm actually sort of double checking myself as I go through this. Is this, I thought this was code, but yes. I'm just making sure I'm talking about the right thing before I go down this path, since these two are almost interchangeable. No, it's in Visual Studio. Okay, I'll have to update my note. So in a lot of the IDEs nowadays, in modern times, when you go to load your project or save your project, if you think about all the configuration you have around that, between your where your Git files are, where your source files are, what Git repo you're using, hopefully you're using Git, not something else, but all these sort of things. There's a lot of aspects around a modern software project. So the IDEs have what's called a solution file, SLN. And that thing has to be able to support all these different things, right? Debuggers, compilers, like I said, file locations, Git. So if you are, the use case here is if you're downloading a solution from third party or from some open source project, there's potential, nothing clear outright, but there's potential for a vulnerability in there to be executed by your IDE. And this is, on your developer workstation where you've got your source code that you're trying to modify. And if something can suddenly do an RCE or something in there, it's not really a good situation. So I know VS Code at the time came up with it, and I guess Studio did as well, along with JetBrains and some of the other guys out there, that you don't automatically trust that solution file when it comes from a third party. I'm going to tie that together with the concept of mark of the web, which is used by most of the major OSs now, that if something is downloaded, it gets tagged with this mark saying, hey, this was downloaded. So when your application then loads that file, it's able to go, oh, this was downloaded from the internet. And it looks like the use case here is sort of talk through it. You can download a solution file into Visual Studio, which should not be trusted. They have the functionality for trusting to ask the user, should this be trusted? It looks like that functionality is disabled by default for the last 2 years in Visual Studio. So you have to actually go in and turn this on. But even if you turn that on, Visual Studio is not paying attention to the mark of the web. So yeah, there's a few sort of slightly sketchy things in there. Whereas those concepts are on in JetBrains stuff, and I believe it's on in VS Code, because I'm pretty sure I've seen it, the trust scenario. So just something to think about, right? We talk about application security and some of these different aspects of it, but if the IDE itself has got issues, again, as I said with the OT stuff, don't worry about going higher up that stack. And I think that's it from me, Mike.
And I think that's a great tie-in back to your article about Mac too, in the sense of power users wanting to configure and enable certain capabilities within their IDEs, for example, but that coming back to hunt them, coming back to bite them, or defaults actually being secure, or in cases of mistakes, missing the mark of the web. So I think it's all of a great... I think I want to end that on by saying it's a good reminder of the user experience, remembering that users are part of the AppSec design and threat models. The idea of a system.
I'll add on to that really quickly. If someone wants to see something haunting, go and take a look at the configuration preferences settings in Visual Studio Code. I'm sure Visual Studio is like same, but like when you add a few modules in there, it just goes on and on and on and on. And it becomes a very complex beast. So I can see lots of space for mistakes.
A complex beast. That might be, we'll have to throw that into our AppSec in 3 words capability or candidates as well. I want to say thank you, John. I want to say thank you to everyone else for joining us. Please do subscribe, hit that like button, check out the show notes. And speaking of Patch Tuesday, check out Patchwork by Thought Beans. We'll see you next time on Application Security Weekly.